Okay, welcome to Lesson 10, Lining Up Quadratics. Today we're going to look at the graphs of quadratics again, so we're going back to the same concepts that we were studying at the beginning of the unit, just looking at them at a different way. I see y equals. I'm going to go ahead and use my graphing calculator, and I'm going to go to y equals, and I'm going to type in the equation, which is x minus 1, so parentheses x minus 1, parentheses x plus 3. I'm going to go ahead and hit graph so I can see the picture. And I'm going to look for some significant points. And let me go ahead and mark some of these significant points. I have positive 1, negative 3, negative 3, and negative 1, negative 4. So on my graph paper, I'm going to go ahead and mark those. All right. So we had positive 1. We had negative 3. We had another negative 3 for the y-intercept. And then we had the point negative 1, 4 for the vertex. Go ahead and connect the points. So my line of symmetry is x equals negative 1. My vertex is negative 1, comma, negative 4. My x-intercepts are negative 3 and 1, and this is not in correct ordered pair forms. Technically, it would be negative 3, 0, and 1, 0. We're just kind of going through the basics today. My y-intercept is negative 3. Okay, so that's the first one. Let's go ahead and clear the screen and move on to the next one. Okay. Same thing. I'm going to type it as I see. So I have 1/2 times x minus 2 times x minus 6. I would type that in my calculator. Go ahead and hit clear. I have 1 divided by 2. Now normally fractions I would put in parentheses. It's just good practice, but I'm going to leave them alone for right now. I have x minus 2 and I have x minus 6. I would press graph. It's a little bit slow, sorry. Okay, and then again I see my significant points. I'm going to go ahead and mark those significant points. I didn't call them out on that last one, but they are 2, 6. My vertex is going to be 4, negative 2. And my y-intercept, I need to look at my graph one more time. And my y-intercept was 1, 2, 3, 4, 5, 6. Okay. On your graphing calculator, the spacing might not be as great as it is on this big screen. So it might be tricky to tell whether it is positive 5 or positive 6, but it is positive 6. So 1, 2, 3, 4, 5, 6. Connect the dots. Sorry, I did that a little sloppy. There we go. So my line of symmetry right here, that is going to be x equals 4. My vertex is going to be 4, negative 2, using the line of symmetry and the lowest point, the minimum. My x-intercept, and again, not in proper form, but it's 2 and 6. And the y-intercept is 6, okay? If you want to see proper form really quick, it would be 2, 0 and 6, 0. And for the y-intercept, it would be 0, 6. Okay, we're going to go ahead and clear the annotations so I can move the screen and get to the next problem. Okay, same thing. We would type it into the graphing calculator and we'd make a sketch of the key points. So go ahead, press y equals, hit clear. We have a negative, don't forget to use the, hit the negative button, not the subtraction. Negative x, x plus 4, graph. Okay, also notice that this one is facing down because of the negative out front. I have x-intercepts at 4 and at 0. My y-intercept is at 0. My vertex is at negative 2, positive 4. Okay, so we had 0. We had negative 4. We had negative 2, 1, 2, 3, 4 was my vertex, and it opened down. This time we only have 3 points because 2 of our points overlap. My line of symmetry is x equals negative 2. My vertex is negative 2 comma 4. My x-intercepts are at negative 4 and 0. And my y-intercept is at 0. Okay, so now we're going to start talking about the patterns that we noticed. Okay, determine the line of symmetry. There's a couple different ways. First of all, the line of symmetry is where it splits the graph in two. If, however, I did not take the time to graph it, there's actually a mathematical way from the factored form that I can calculate the line of symmetry. Okay, so in the first problem, we had x minus 1, and then we had x plus 3. And my intercepts were 1 and negative 3. All I do is the line of symmetry is the average of my x-intercepts. So I'm going to do negative 3 plus 1 divided by 2, which is negative 2 divided by 2, which is negative 1. So to determine the line of symmetry, it's what cuts the parabola in half. It's the x value of the vertex. And to get it from factored form, you would take the two x-intercepts and average them. My vertex is my line of symmetry. And it is an ordered pair, so it's my line of symmetry. And then either the highest or the lowest point depending on if my parabola opens up or opens down. So it's going to be the highest point or the lowest. So the max or the min, the y value. Okay, determining the x-intercepts. The x-intercepts is where it hits the x-axis. And if we go back to problem number 1, to determine the x-intercepts, it is actually the opposite of the factors. So right here it says minus 1. So my x-intercept would be positive 1 and negative 3. It is the opposite of the factors. Y-intercepts. Okay, the y-intercepts is where it hits the y-axis. And there's also a kind of cool way to do it. You could do the y-intercepts, treat each of these, well, we're going to see a shortcut in a second, but the let's stick with the y-intercept is where it hits the y-axis. I'm going to show you a shortcut in a minute. Okay, the dilation factor is any multiplier in front of the factors. So like our GCF that we factored out at the start, the only one that we have is in problem number 2, we had 1/2. That would be a dilation. Okay. In number 3, you see the negative x. A dilation is going to be a numerical factor, and the negative is not a dilation, it's a direction, whether the parabola opens up or opens down. All right, let's continue on. Okay, so I see that it says to pick 2, but in order for us to have a similar discussion, we're going to go ahead and I'm going to pick our 2 equations. So I picked y equals x plus 4, and I chose y equals 2 times x minus 3. And what I'm going to do is I'm going to replace x with a number to find out what y is so I can plot some ordered pairs. So I'm going to do this one in pink. So if I replace x with 0, that's 0, 4, 1, 2, 3, 4. If I replace it with 1, it's 5, 2, it's 6, and so forth. I start to see a pattern, up 1, over 1, continue my pattern. I'm going to take out my straight line tool and connect my dots so it's a little bit neater. Okay. There we go. Now, I'm going to do this one in blue. So same thing. I'm going to pick some. I'm going to start with 0. 0 minus 3 is negative 3 times 2 is negative 6. 1, 2, 3, 4, 5, 6. Then I'm going to replace it with 1. So negative 2 times 2 is negative 4. then replace it with 2. It's going to be negative 2, and I start to see a pattern, which is up 2 over 1. I continue the pattern, and I'm going to go ahead and do a different color. Connect my dots. There we go. All right. Now they'd like us to find, in problem number 6, the product of my two linear equations. Product, remember, it means multiply. So 2 times x minus 3 times the x plus 4. Okay, I need to clear some of my annotations. Okay, and scroll the board so we can have a little bit more work. Okay, so I had 2 times x minus 3 times x plus 4. You guys decided that we would double distribute first, so that's what I'm going to do. X times x is x squared. X times 4 is plus 4x. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. Cleaning it up, I get x squared plus 1x minus 12. I forgot about this 2, so let's bring the 2 in. And we get, it's going to dip into the next problem, sorry, 2x squared plus 2x minus 24. And now what I'd like you to do is it wants us to graph it as well. So go ahead and press y equals on your graphing calculator and type in the equations. So let me do the same thing. Clear my annotations. All right. I need to move these 2 lines out of the way for right now. We'll bring those back. Okay. I'm going to press y equals. I'm going to clear out what I already have there. I want 2x squared plus 2x minus 24. I also would like x plus 4, and I would like 2 times x minus 3. And I'm going to go ahead and hit graph. Okay, the blue is my parabola. The red is the first line we graphed in number 5. And the black line is the second line we graphed. Okay, now, unless we scroll down, you can't see the vertex, but you kind of get a feel for that. So we're just going to do a rough sketch. So let's go back to number 5, and we're going to add the parabola, making it a rough sketch. Okay, so we had our linear functions. My pink line, my blue line went through. Oops. Okay, it went through 4. There we go. And then this one was supposed to go through 3. Okay, we're great. Okay, now the parabola went and it hit both of these. We kind of didn't see. Somewhere off the screen down here was my vertex. But I'm going to show you some patterns to kind of make it easier to determine these. So if you forgot your graphing calculator, or you know, some of you like math patterns and like to do problems a little bit quicker than typing in the calculator, you would have all these. So we're going to go ahead and clear the annotations. I'm going to move the screen down. Okay. So we're going to talk about the relationships. They want to know the x-intercepts of the 2 lines. So the first line, the x plus 4. Okay, my x-intercept was x equal to negative 4. My x-intercept was negative 4. And when I had 2x minus 3, my x-intercept was positive 3. Okay? When you look at the graph, you will notice that the x-intercepts of the parabola are the same. They are also positive 4 and negative 3. The reason why is the parabola is made up of the product of those 2 lines. So their x-intercepts are going to be the same because the parabola is made up of the product of the 2 lines. Okay, moving on to discover other patterns. Okay, let's talk about the y-intercepts. Okay, so the first line that we sketched, the y-intercept was negative 4. I'm sorry, it was not negative 4, it was positive 4. It was positive 4. and then the the y-intercept for the second equation was negative 6. And I will tell you that the y-intercept for the parabola is negative 24. So how did we do that? Well, the relationship between the y-intercept of the linear functions is equal if I take the product. So the product of y-intercepts of the linear is equal to y-intercepts of the parabola. Pretty cool. Remember also to find the y-intercept, we're just replacing x with 0. So I just want to go back to the original couple of problems. So let's go back to the very beginning so you can see this pattern. So the y-intercept is the product of the y-intercepts of the linear equation. So let's go back in time. So remember, y-intercept is when x is 0. So if I replace this with 0, that's negative 1. Replace this with 0, that is 3. Negative 1 times 3 is negative 3, which was the y-intercept for this equation. Okay, moving on. Let's look at the next one. Okay, so here, if I replace this with 0, that's negative 2. Replace this with 0, I get negative 6, and that gives me 12. Wait a second. You told me that the y-intercept was 6. Well, we got to account for the dilation factor. So when I multiply this by half, I get 6. So a really cool way to find the y-intercept for the parabola is just replacing the x's with 0. All right, moving on. Okay, here we go. Number 9. They would like us to sketch two lines that could represent its linear factors. Okay, so we know right here is a factor and right here is a factor. So what is an equation of a line that would go through this dot? Now many of you would tell me, and some of you did, you said x minus 1 because this is a negative 1. Let me start substituting in numbers. If I put in 0, 0 minus 1 is negative 1. So 0, negative 1. And then if I plug in 1, 1 minus 1 is 0. And the line goes this way. It never goes through that dot. So think about some more patterns that we started to notice. What could I do if x minus 1 doesn't work? What do we think works? Okay? Hopefully you notice that I can change this to a plus because the factors and the equation are opposite each other. My factor, this point right here, this negative 1, well, let's get the factor, is opposite this equation, which contains a factor, is the opposite of the negative 1. I'm trying not to reveal some of the vocabulary for future lessons. So if I replace that with 0, 0 plus 1 is 1. And continuing the pattern, there we go. The line goes right through that dot perfectly. So if I want to go through negative 1, I used x plus 1. If I want to go through positive 3, I'm going to use, so we have x plus 1. I'm going to use x minus 3. Okay, so we took care of number 9. Number 10, there's my factors. Let me erase this out of the way. And notice when I come up with the two equations, it is the opposite of the point. So instead of negative 1, it's going to be positive 1. Also think of us plugging into that vertex form. It's x minus, so x minus a negative 1 turns it to a positive, trying to bring everything back around. How do you use the x-intercepts and the y-intercepts of the parabola to determine the graph of the equation of each line? Okay, so the way we use the x-intercepts is we did the opposite. We did the opposite. Okay, now the y-intercept, remember the y-intercept should be the product of these two. So my y-intercept is the product. My product of my x-intercepts. Okay, so negative 1 times 3 is negative 3. And then to find the x-intercepts, I use the opposite sign to create factor. Okay? Are these the only two lines that could represent the linear factors? No. I mean, I could come up with another equation that would go through -1. There's a couple different ones. Okay? Now, are they the only ones that represent the factors of this parabola? Well, we need to check and see. So let's scroll down. Okay. And I'm actually going to do 13, and then we'll come back and talk about number 12. Okay, use the two lines to write an equation of the parabola. Well, right now, we think it is x plus 1 times x minus 3. The only thing that could mess us up is if there's a dilation factor. But remember, that would have to factor into my y-intercept. And right now, -1 times 3 is -3. So there shouldn't be a dilation factor, okay? That's one proof. 1 times -3 gives me the -3, so that means there shouldn't be a number out front other than 1. Another way to test it is let's go ahead and let's plug in some numbers and see if they match up with points on the graph. So remember, I always pick good points that I can clearly see. Okay, so I'm going to start off when x is -1. -1 plus 1 is 0. And then -1 minus 3 is -4. 0 times -4 is 0. Okay, so -1, 0, check. Then we have 0. If I plug in 0, 0 plus 1 is 1. 0 minus 3 is -3. 1 times -3 is -3. Okay, so let me visually show you because some of you, me talking it out might be a little challenging. Okay, so 1. I'm going to plug in 1. So 1 plus 1 is 2. 1 minus 3 is -2. 2 times -2 is -4. So when I plugged in 1, I should get -4. 1, -4. Check. Okay? Now I'm going to replace 2. I'm going to plug in the number 2. 2 plus 1 is 3. 2 minus 3 is -1. 3 times -1 is -3. 2 and -3. And I would keep checking this. So I believe this is the equation of the parabola because when I plug in the factors into this equation, they match the points on the graph. Okay, so coming back to number 12, which I already answered, but just I wanted to show the proof. There are other linear factors that could go with this parabola because they would go through those 2 points. But when I did the mathematical test, I found that this one worked. Okay. Good job.